And yep, I'm live with the stability VPS and FPS, and YouTube also knows that I am live, so we are good to go. Yep, yep, we are good to go. And CB31, let's just begin. Yep, I guess we'll do all of these questions. These are just 6, so let's see. Yeah, code force is not down, so that is cool. You are given an integer n. Check if n has an odd divisor greater than 1. Does there exist a number such that a number x which is greater than 1 that n is divisible by x and x is odd? Okay, for example, n is 6, and then there is a number 3, and if n is 4, then such a number does not exist. Okay. Okay, so I just have to output yes or no. So 2, mm, 2, 3, 2, 3. Okay, I have to prime factor this number. See how many times I can divide this number by 2. And yeah, if I can divide this number by 2 multiple times, then we are good to go. Yeah, if this number is a power of 2, then the answer is no. But if it is not a power of 2, then the answer is yes. So, hey, what? 6 is the number of test cases, yes. And 2 is a power of 2. The answer is no. So, then 3 is is not a power of 2. Then, yeah, the answer is yes. Then we have 4, which is no. Then we have 5, which is yes. And then if the number is odd, then of course. And then the 6, I guess. And n is pretty huge. Okay, that is cool and pretty much doable. Wait, shit. Tmux detach, tmux attach, TCP in here, and maybe I can shit here. Yep. What the heck? Boilerplate. Then int 6 called n in n. Now, if n remainder 2, then we can just outside yes right away. Otherwise, you will have to see what we can do. Else, if it is not, then I have to check is it a power of 2, and how do we check that? Just keep dividing the number by 2 and see if at any point the remainder is 0, right? So while n remainder 2, not while not not n remainder 2, what I have to do is n equal by 2, not remainder, right? Not remainder. And if there is a remainder at some point, then it will just get out. And if the thing is always divisible by 2, at the end I should get 1. Now if n equal 1, then we are good to go. Otherwise, no. If n equals 1, then see out no, else see out yes. Let's see, and that is correct. Submit. The name is a odd divisor. Okay, shit, not here. Documents, programming. A odd divisor and submit. Let's see. I guess it will work. It is in queue, running, taking time, still running. Mhm. Accepted. That is cool. You can go on the next one. Strange pattern. Yeah, you are given an array A of length n and an integer x and an integer x. In an array A of length n and an integer x, you can perform the following operations as many times as you like, possibly 0 times. Replace two adjacent elements of the array by their sum. For example, if the initial array was this, in our operation you can replace the last two elements by their sum. So okay, so instead of 2 I would have one element, or replace the first two elements by their sum. 6 plus 3 plus 6 is 9, so the total sum of the array is same. Note that the size of the array decreases after each operation. The beauty of an array b equals from 1 to k is defined as when summation, okay, take the ith element divided by b and take the upper limit of that, the ceiling, and sum it for all the elements. Okay, which means that we divide each element by x, round it up to the nearest integer, round it up to the nearest integer, and sum the resulting values. For example, x, if x equals 3 and there is this, then you have 2 plus 4 6 plus 2 8, and the value of the array is equal to 8. Yes, these determine the minimum and maximum beauty you can get by performing some operations on the original array. Fuck, by performing some operations on the original array. Okay, shit. The maximum and the minimum beauty. Okay. Input first is t, then and the first line of each test case contains two integers n and x, and then next is the number of the array itself. Okay, and okay, n is small and x can be big, and it is guaranteed that the sum of the values of n over all the test cases does not increase 10 power 5. Okay. Okay, I need to increase the beauty to the maximum. Int n and x, cn n and x, and then a vector of integers called a, size n, and repel I 0 n cn a bracket I. Now, after taking the whole array in, I can do operations. Okay, if since this is a ceiling function, then would it even be beneficial to do the summation if both numbers are do have a remainder, and adding them would give 1 and 1, but keeping them separate would give 1. Okay, the thing is about remainders. So instead of storing I in A, I can store the remainder, and which would work the same way. C in into C, and then A I equals C remainder X. And now the minimum I and also shit, yes, and the sum which would be fixed S sum, which is initially equal to 0, would be sum plus equals C divided by X. We are cool. And minimum would be add all of them together. Yeah, I don't think. Yeah, the maximum would be just add. Okay, I think I can calculate the minimum and the maximum right here, and the minimum I would have to calculate later. Okay, so uh, min initially 0 and max also initially 0. Do I need the remainder? No, 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 no. Min, I don't even need the array. Min plus equals C remainder X, and yeah, some would be constant in both, and max plus equal 1, right? If C divided by X is something, then max plus plus, otherwise don't. And then min equals sum plus min, sum plus min, first of all, means remainder. Yep. Plus 1 plus, yeah, either 1 or 0, depending on if not sum but min remainder X. Yep. And max is sum plus max, right? Sum plus max. Yes, sum plus max. And then see out max and then minimum and then max, minimum and then max with a new line, of course. Let's see, run and error. Okay. 6 is cool, but 7 8 is not cool. In the last one, I'm saying that the minimum is 6. Let's see. This is 3. So if I were to add this, and this, I would get 21, which should be 7, not 6. Makes sense. And the value of sum should be 3. 1 plus 2. 1 plus 1, 2. Wait, 2 for this, 1 for this, 3 in total. 3 plus 3, 6. So 6 we have as the base. And then, yes, I added 1 for this in max. And then for minimum, the remainder for this was 0, for this was 1. And the remainder for this was 2. 1 plus 2 is 0. Makes sense. Yeah, shit. So in minimum, don't add this, but instead add ceiling of min divided by X. Yes. Now we are cool. It is called a strange partition. A strange partition. This one. Let's go. Shit. Wrong answer on test 2 itself. Crazy. Expected 4, found 0 in the first case. Uh-huh. Expected 4, found 3. Okay, I'm saying that 3 is the minimum, and it is saying that 4 is the minimum. But then 9 is cool. Okay, so maximum is cool, but minimum, I messed up somehow. 93. So add this. Take the sum and take the ceiling of the sum. So in minimum, instead of instead of having like sum and then this, I could say I could take maximum and minimum simultaneously. Minimum this, and after taking C, min plus equal C, add C to minimum, and maximum plus equals C, ceiling of C divided by X. Yeah, ceiling divided by X. And C is this, and afterwards minimum becomes ceiling of C divided by, not C, but min divided by X. And see, that does not work for this. Ceiling of C divided by X. Hmm. 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 So this is cool, but this is not cool. Why? Ceiling of this would be 2, for this would be 2, and for this 4. 2 plus 2 plus 4 should be 8, but it is not somehow 8. It is 6. Ceiling, right? Ceiling. 2 plus 2 plus 3. It is not 6 in any case. Maximum is initially 0, and then I'm taking C divided by X. C divided by X. Let me make X not an in. What is the maximum value that X can have? The maximum value X can have is 9. That's not cool. Maybe I can typecast this thing into float. Let's see. Still wrong. Minimum float divided by X. Take the ceiling of that and do this. Minimum, for minimum, add everything, and for ceiling, maximum plus maximum is initially 0, and then maximum plus equals ceiling of C divided by X. Ceiling, right? Ceiling is cool. This should work. Ceiling is working here. Minimum, maximum, C. This should work. This should work. Let me do this. C out. Max at every point. Run. And we have 1 3. For this we had 2 plus 3, and then okay, so for the second case it was just 1. No, it was just 1 due to some reason. It should have been 2, and then it became 3. Yeah. So 2 plus 1, 3 plus 3. So it is not giving out the ceiling. That is the problem. This thing is not giving out ceiling. I don't know. This thing is not giving out ceiling. Why? C is an integer. Yep, C is an integer. Int by int in C++. Mm-hmm. Not 3, 3. Mm-hmm. How do I fix it? Static cast double shit. Cast then. Maybe now. Now it is working already. Yep, cool. Submit. Running. Right. It just says running. Wrong answer on test 2. Again. On the first number itself. Expected 4, found 3. But why? Expected 4 but found 3. So if I take the sum of all these numbers, I should get the sum of all these numbers. And then if I take the if I do this. Okay, I guess the same problem is here. Now it should work. Submit. Some coffee. Yeah, we are getting somewhere. The concept is right, but the implementation is wrong. Min plus c y, but the solution is sign integer overflow. Wait, what? Signed integer overflow. And the third one. Shit, I had quite a few numbers. On test 3, verdict, wrong answer. Outruns this and this. Check answer, wrong answer first. With expect this found 2. Okay, let me make it bigger. This will, well, of course, work, but okay. Yep, that makes sense. It is actually pretty stupid to do this. To keep doing this instead, I should plus equals c remainder by x. And yeah, the initial approach with sum was pretty cool. Sum equals 0. And it is sum that sum plus equals c divided by x. And then minimum equals sum plus seal of seal double minimum divided by x. Let's see, and yep, that is cool. And okay, submit. Yo, Code Force is back online. I see. Yep, it is back online. That's cool. It is in queue. It works this time, I guess. Shit. Okay. Running on test line. Mm-hmm. And 12. And shit. Is it slow? Nah, I'm only keeping the things that I need. The sum that I do want, maximum, and this and minimum. Mm-hmm. Shit. A cool trick of getting the ceiling of integer division here v is a plus b minus 1 divided by b. A plus b. I have seen this before, but shit, yeah, I did saw this before. And you can just do integer division instead of converting to double. No, integer division was not working because I think when I divide this integer with this integer, I get an integer and the ceiling function was not working. And yeah, the ceiling function was not working. But this a plus b minus 1 divided by b. Okay, let's see. A plus b minus 1 whole thing divided by b would mean a divided by b, our original thing, plus 1 and then minus 1 by b. Which is simply a minus 1 divided by b and plus 1. A minus 1 divided by b plus 1. A minus 1 divided by b. I will get that. And then plus 1. Will this work? A minus 1. I want to go there. And minus 1 takes me there. Divided by b. So this is still not adding up. A divided by b plus 1 minus 1 by b and a minus 1 plus 1. Wait, see, if a is some number, right, like this, and b is another number, and b is, let's say, this big, so it can divide a in like this, and yep, like this. But yes, now when I do normal a divided by b, I would get 1, 2, 3, 4, 5 as the answer. But I want 6 as the answer because I want to take ceiling and go up till here. I want 6 as the answer. So what this thing does is it reduces the value of a up until like this point, and when I divide that by b, I would get 1, 2, 3, 4, and then adding 1 would just give me this. So it is not giving me till here. I want the value to go till here. It is not working. If the integer division is this, the integer division is this, a plus b minus 1 divided by b. So if a is multiple of b, then we do k b plus, yeah, kb plus b minus 1, which is just k k plus b k plus 1 b, which is just k after integer division. But if a is not a multiple of b, then we get k plus 1. Okay, kb, we would get k. Yeah, we would get k plus 1, k plus 1 b, k plus 1 b divided by b, and 1 by b would be 0. Okay, so when it is multiple of b, then we are good, but otherwise if it is not, then we would get k plus 1. How? If it is, let's say, no, white, we can write a as ab plus c plus b minus 1 whole thing divided by b, which would mean in bracket k plus 1 into b divided by b plus c minus 1 divided by b, and which would mean the same. If we do not have a c here, then this is what we would get, k plus 1. Shit, am I doing something wrong? kb plus b minus 1 whole thing divided by b, k plus 1. Shit, why is the answer k plus 1? Yeah, k plus 1b. If we take b common and divide b by b, we get 1. We get k plus b, k plus 1. And shit, we should have gotten a. No, like we should have gotten k. But we are also doing minus 1. That is, okay, shit. Since the answer is going to be integer, so we are subtracting some value that is lower than b, right? 1 by b. So, and since the answer is going to be integer, so the answer would be equal to k in this case. Okay, that makes sense. But in here, we would get k plus 1 out of this term, and out of that other one, we have c, which is smaller than b, and c minus 1, which is still smaller than b. And shit, now this thing is in addition. Okay, and since we are going to get an integer, so we get k plus 1 plus some small thing b, which is greater than 0 but less than 1. So, and since this is going to convert into an integer, we will get k plus 1. That does make sense. That does make sense. Equals k, not k plus 1. Uh, If a is not a multiple of b, then it can be written as kb plus c, where c is greater than 1. So adding b minus 1 makes sure, adding b minus 1 makes sure we end up with k plus 1 plus some remainder we don't care about. And yeah, yeah, adding b minus 1, we are adding some value that is not b. Okay, you can separate fractions. CPP will evaluate the whole thing and whole denominator. Yep, this makes sense. You would get k plus 1, and instead of using ceiling function, we can do this. That is cool. And this one was accepted. That is also cool. Now this sum of medians. Median is the like middle value. How the numbers are to the right of this and how far to the left. A median of an array of integers of length n is the number standing on the n divided by 2. A median of an array integer n is the number standing on the n divided by 2 rounding up position. in the descending order of its elements. Makes sense. Descending order. If n is even, then the median is plus minus the middle two elements and divided by 2. But if it is odd, then we can have the middle element, doesn't matter. Right? Ordering of positions are numbered starting with 1. Okay, for example, a median of this thing is equal to 3. There exists some other definitions of the median, but in this problem, this is the one we described, given two integers n and k, and non-descending array of nk integers. Okay, divide all numbers into k arrays of size n such that each number belongs to exactly one array, given two integers n and k, and a non-descending array of nk integers, non-descending. Okay, it keeps on only increasing. Divide all the numbers into k arrays of size n such that each number belongs to exactly one array. You want the sum of the medians. You want the sum of medians of all k arrays to be the maximum possible. Find the maximum possible sum. You want the sum of medians of all k arrays. K is the number of arrays we will make to be the maximum possible. Find this maximum possible sum. Mhm, mhm, mhm. Okay, okay. Yeah. Maximum possible. Okay. Input first. You will get n and k and then nk elements. Okay. Which are non-descending. Keep on increasing. If I have something like this, okay, I will have in this case 4 arrays of 2 elements. This, and the definition for a median is this. N divided by 2, take the ceiling of that number. So if n is 2, I get 1, which is the first element, in this case 0, then this, then this, then this, if I were to just divide them as they are. But I could do a bit better. I want the element in that particular position to be the maximum that it can be, right? But since, right, in the non-descending order, okay, in the non-descending, since, and I would like to maximize the sum. Oh shit. So I would like to have at the median position the maximum possible element possible, and since there are bound to be numbers after it, yes, since there are bound to be numbers after it, then those numbers will have to be bigger than this number. Mhm, mhm. They will be bigger than this number. Uh, mm. Okay, so let's say I have the array with which is going to have the maximum possible median, and the maximum possible median cannot be this number. It can only be this number, because in the array with the maximum possible medium, I will have some element to the right of it, and those elements would have to be in non-descending order. Therefore I need to the right, in this particular case, one element, and the maximum possible element is this. So I have this to the right, and then I can have this. Then my first array is complete with this as the maximum median. Now I would like to have another medium, and then I can just say that this does not exist anymore. And now I have to do the same thing with this. And in that case, this would be the maximum possible medium. median, and then I can do the same thing with these four remaining elements, and this would be the maximum possible median, and then this. So answer would be 0 plus 34, 34, 34 plus 62, 96, 96 plus 69, 170, 196, 165, 165. That is cool. And in this case, this plus this is 90. Shit. Okay, that is not correct. Shit, yes, it is correct. 108, 108. That is cool. Now, since we need some elements to the left, I think here is some cheating that we can do. Okay, after making an array, we would have three arrays, right, of size 4. Yep. In this case, we would have three arrays of size 4, and the maximum possible median 4 divided by 2 is 2. So the second element in the array, in the subarray, would be the median, and if this is our subarray, then 91 would be the median. Now the maximum possible median for the biggest array is 91, and then I would need a number that is smaller than 91 to put on the left side, and I can put the smallest number here, so that this is my remaining array, and in this the maximum possible median would be 36. So 91 plus 36, and then I can put 4 to the left of it, and then I have this as the remaining array, and the answer would be 18. So 18 plus 36, that is 40, 54, and 54 plus 91, 55 plus 91, 45, 145. That is the answer. Okay, so what I would like to do, how can I pick the answer? What would be my algorithm? There are certain numbers in the start that I can leave, and that would be, since I have a median, n is 4, so I know that I would have one number to the left, and okay, one number to the left which I can leave out, and since I have k such subarrays, so I can leave out 3 into k numbers on the left, these numbers on the left, and starting from here, uh, how many numbers do I have to skip? I have to skip this 2 numbers, and then add the one, and then skip 2 numbers, and then add the one, whatever it is. So okay, this skipping part is cool, adjustable. How do I get on to this skip 2? Skip 2 is also easy. Whenever I skipping 2 would mean like every third element, every third element, 9. Okay, and okay, 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 makes sense. I got this. Click boilerplate. How is the input given, by the way? Shit, I was looking at the input this whole time. I have n, then I have k, and the range is also fine. And n, k, let's say c, and okay, I will see what else I need. N and into k. Then do I need an array? Nope, I do not need an array. It's running from 0 till n into k. That is the number of numbers I have, and we'll take in the current number in c. And what else do I need? C into c. Wait, I need, how many numbers do I have to skip? And yeah, how many numbers do I have to skip in the start? And what is going to be the skipping step, right? Okay, does it make sense? Yes. So the numbers that I have to skip. So median position would be, and mid pause is equals to, we will use the new method that we just came to know how to do, k plus n plus 1 divided by 2. That is the median position, and n median position, no, minus 1 is the number of things on the left. Okay, and left is mid pause minus 1, and on to the right mid pause minus 1 plus 2, that would be the skipping, and skip equals n minus mid pause plus 1. Is that correct? N minus mid pause plus 1. Yes, that is correct. And how many do I have to leave? Ignore. Uh, Ignore this into k. Let's say 1, ignore 3. And since I is starting at 1, mm, start I at 1 and repeat, repeat till equal. And if I becomes greater than, ignore, right? That is, now from now on I have to start considering these elements, and if it is 4, the boundary would be shit. Yeah, it would be bad. 4, 3 numbers I left, 1. Yep. So yeah, if I minus 1, and also one more thing, if I minus 1, remainder with skip, remainder with skip, or more like not remainder with skip, not remainder with skip, then I can add. That is my median for that array, or that subarray. Yeah, shit. Median, mid plus equals C. Is that correct? Yeah, seems like it. C out, mid, new line. Let's see. Fuck. That is horribly wrong. Shit. Let's see, n into k. Shit, that is actually horribly wrong. Why is it like this? Oh yeah, I didn't initialize it. Okay, alright. Mid equals 0. The start. Now it is correct. Okay. Yeah, I didn't initialize it. B sum of medians. Let's see. It is in Q. It might break, or yes, it might actually break. Expected this, found a larger number than I was supposed to give, and this. Okay, so this is of course the fault of this thing. This thing, and repeat equal in the second one. Let's see, submit. Fuck. Okay. In view, at least I guess this one wouldn't have negative numbers. Yeah. And are these other numbers matching? Nope. Nope. Okay, these are matching 101 triple zero and 19199. Not matching. Not matching. Expected this, found a larger number. Non-descending. Hmm. 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 These are the numbers that I have. Okay. These are the numbers that I have. 8 and 7. So the maximum median that I can have would be, I can skip this. 8 and 7. 7 is the number of arrays that I need to make, sub-arrays that I need to make, and 8 is the median. So fourth element, I would have 4 on the right, so I have to skip 4. I have already removed 1, 2, 3, 4. This is the first median. So 91 plus, after 91, I need to have 3 elements to left, and which can be these 3. Right, cool. Then the greatest would be the greatest median would be to remove this 2, 3, 4, and this 78. So plus 78. Then I can remove 78, and from the start I can do 1, 2, 3, 3 elements from the start. Then the greatest would be 71, 73, 73, right? Yes, seems like it. I can remove 73 from here. No, what the fuck? No, no. After this, I need to remove 4 elements. 1, 2, 4. 68 is the next one, plus 68. And to counter that, I need to remove 3 from the start, like that. That is cool. And now the greatest would be, first of all, remove this. Then 1, 2, 3, 4. 59 plus 59. Remove 59 first of all, and from the start, remove 3. 1, 2, 3. Now the greatest would be 1, 2, 3, 4. 48 plus 48, and remove 48 first of all, then remove 3 elements. 1, 2, 3. Then the next biggest median would be 1, 2, 3. Yeah, 1, 2, 3. Or 4. Then 42 plus 42, and in the start would be 1, 2, 3. I think I messed up at some point. Remove 142, then add the next greatest by removing 4. Yeah, I did mess up at some point. My algorithm should have worked. I am leaving 3 numbers to the left. 8 is my median, right? So fourth element has a median, so Wait, what is the name of the question? Sum of medians. Very innovative. Okay. After taking n and k, n is equal to 8 and k is equal to 7. Mid position is k plus 1, 8 plus 1 divided by 2, which is 9 by 2, which is 4. So 4 is cool. Then ignore, should be 3, and which is mid position, minus 3, 4 minus 3 into k. Yeah, that is cool. K is 8, so which means 3 into 8, 21. I can discard the first 21 elements, and then yeah, then we get to skip. How many I have to skip? I have to skip 5. N 8, 8 minus 4, 4 plus 1, 5. I have to not skip 5, but every fifth element. I have to add every fifth element. So take in C, the first element, and go till I becomes greater than ignore. I have to ignore the first 21 elements. So when I becomes equal to 22, that is the element that I will take in. And if I, which is at this point 22, 22 minus 1, that is wrong. 22 minus 1. Shit, I have to also minus ignore. This makes sense. 22 minus 1 and yes, minus 1 minus ignore, which is 0, and yes, and starting from here I will get every fifth element. Shit, why didn't this mess up here? Okay, that is cool. Now it should work. That was the only problem. Submit. And due to some reason I have Vsauce music in my head. That is strange. In queue, running on test 6. On test 9 and accepted. That is cool. Sum of medians, 3 indices. It has been 58 minutes. It is lower than yesterday. Yesterday I did 4 questions, 5 questions in 40 minutes. You are given a permutation. Recall that sequence of n is called a permutation if it contains all integers from 1 to n exactly once. Exactly once. Find 3 indices I, j, k such that I is smallest, then j, then k, and they are not equal. So that pi, pj, j is greater than I and k. Okay, or say there are no such indices. Okay. I'm looking for, okay. Any 3 indices, right? Yes, and this, yes, and this, and then no. Okay. In this case, I do have it. 4 is a. I will look for the largest, then the second largest. The only case that this is not possible would be when it is in the ascending order. Okay, if I have a 1, 2, 3, da da da, and da da da. Okay, since it is a permutation, therefore it becomes easier. Will be 11. How is the input given? N, and then the permutation itself. Okay. Int n, right, and cn n. Okay, and then repeat less I 0, I repeat equally I 1 till n, or till equal to n. Now cn, take in the current one, cn to C. Now, if C is not equal to I, that would mean that C is greater than I. Yes, C is greater than I. And if that is true, then we already have our I and J, I, J, J and K. And let's see, removed or like later. Okay, if this is true, then I equals I and J equals, wait, I equals I is crazy. Shit, I have to use some other thing here. X, or maybe I here is my one, but here I'll use X. So I equals X and J, nope, no, 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 shit, maybe that element is the first element. And if that is true, then no, then no, then no, no, no. Then also we would not be able to do it. Yeah, then also we would not be able to do it. If it is in ascending or descending order. Hmm. Yep, yep. If it is in ascending or descending order. Take the array. Yeah, that would be the only case that it is not possible. When the permutation is either in ascending order or in descending order. Right. And for descending order, I can check by if right, if C equals X, then it is in ascending. Either this is not true or C is not equal to N minus X. Right. Both of these cases have to be false. Both of these cases have to be false. C cannot be equal to X. First N, I want N at the start and N at the N minus X. X is 1 at the start, and if C becomes equal to N, then I have to want minus 1 minus plus 1. Yes, yes, plus 1. Then put, I would know that this particular element right now is out of place, and its index is this out of place element's index is X, and the one before it, shit, what if it is descending or ascending? Right, this is out of place, so I should have, nope, I'm not guaranteed to have an element to the left of it that is smaller than it. Yeah, yeah, makes sense. I'm not guaranteed to have it. Mm-hmm. Mm-hmm. Yep, makes sense. I'm not guaranteed to have a smaller element to the left of it. Mm-hmm. Yep, unless, unless, unless that one particular case, yeah, when it is greater than that, and so this does not give guarantee of being the element that I am after, some element being out of place. But if this is a thing, then I at least know that we have a possible candidate. Hmm. I can check. Shit, I can check if the current element is greater or lower, but also, yeah, shit. Maybe I can. Shit, I can just store the thing in an array. VIA and instead of this, just C into AI or like AI minus 1 or just AI start at 0 group till less than n. Now, also I would at the same time check if it is descending or ascending. X. And to check sorted is 0. If x not equal to n, x not equal to c, and we have x not equal to c, c minus, what the fuck? If c is not equal to x, n minus x plus 1, then sorted equals 1. If not sorted, then we do this. Otherwise, C out. Nope. Now, if it is not sorted, then I need to find an element that is out of place. Any element that is out of place. The biggest element, then the second biggest. None. Uh, mm, I need to find an element. I have the current element and it's, if it is, I need to find just J and then go from J to both sides till I find an element that is smaller. And to be guaranteed to have an element on both the sides of J, which is smaller, what can I do? Which is smaller than whatever the value is at J. What I can do is I have to keep going. I can, well, obviously look for the largest element, but it could be at the side, and then look for the second largest, third largest, and but that is not cool. Yep. Boom. Second largest, third largest. No. That is not going to work. I can. What is the condition when I am guaranteed to have an element to the left and to the right that is smaller? Okay. Okay. Let's say I have guaranteed. Yes, guaranteed is a strong word because, yeah, guaranteed has to cover 100% of the cases, but average does not. Okay, let's see. If I have, so the ideal, okay, if for, repeat equal I starts at 1, goes up till n is equal. Then look for an element that is out of place. If I have a number and the current number in C equals a bracket I minus 1, that is the current number, right? Shit, let me replace it with x, okay? Replace it with x. This is the current number, and how many numbers are bigger than the current number or larger? N minus the current number? Yes, n minus the current number. N minus current number, that is how many elements that are larger. And if someone intentionally puts these elements in such a way, yeah, yeah, if this is this, and let's say this ith position is this x position is such where n minus c, that is the numbers that are bigger, is smaller than the numbers to the left of I of the current number and smaller than the number of numbers I have on to the right. So if n minus c is smaller, then how many numbers do I have on the left? On the left I have, since x is x, if I am to x minus 1, that's 1, and n minus c is smaller than 2, 4, 4. Yes, n minus x, n minus x. Shit, I didn't get it. And c is less than x. Fuck. C current is less than x. How does that work? X is the position, and somehow this does work. N minus c is how many numbers are that are bigger than this number, right? We have 5 and c is 3. Then I have 1, 2 elements, 4 and 5, which are bigger. So 2 elements and n minus c. And if I find this at, let's say, the third position, then n minus c would be n minus x, that is 2. Bro, that is cool. If this is the case, then j equals x. Fucking hell. And now I would like to go to the left and to the right of j after this loop till I find a number that is smaller. Right? I can just break after this. Now repeat, and yes, bear in mind j is 1 indexed. X 1 n. No, no, no. First I have to go left and then I'll start going right. I will need custom loop for int x starts at j s j while x greater than 0 and x minus minus, I'm going to the left. And if the current element, which is a bracket x minus 1 is smaller than a bracket j minus 1. Then we are cool, I can break, and before that I equals x and break. Then do something similar here. No, nothing similar. Uh, repeat equal x starting from j and going up till n. Yes. Now if a bracket x minus 1 is smaller than a j minus 1, yes, then I equals x and break, not I equal x, but uh, j equal x, x, shit, repeat. Now we are cool. J equal x, k equals x. See out, yes, new line, ijk, right? Yes, I, j, k, running, says no, but if not sorted. If x is, it is sorted if x equals c, and if x cannot be equal to c, and and shit, what the heck is x? Is x. Yes, x is the one. If c is not equal to x, the current one is not equal to the, my bad. Fuck. Okay, so due to some reason it is coming out to be sorted is true, but I'm checking if it is false. Shit. Okay. Wow. Segmentation fault. And here, this starts at 1 and goes up till n. That is the size of our array. I am not doing anything stupid, I think. Nope. X minus 1 and minus c x minus j equals x, j equals x, k equals x, I equals x. And it starts at x, goes up x minus minus, and in the lower case, we do x plus plus, uh, up, up until n, and while x is greater than 0, start at j. Mhm. At which part did it break? X, 1 and n. X, 1 and I'm getting out of this. I Hello. Let's see. Nope. Segmentation fault is here. Nope. Even before that. Fuck. You know what? Keyboard stopped working. Wait a minute. No, it is fine. Shit. Bruh. Mm. Yeah. X -1. That is the router. Okay. It does say no here. Ascending, descending, or yes. Even in that case. But this is special. I think in this part. Shit. IJK. Yeah, shit. In every part, my answer is wrong. Shit, my algorithm is wrong. Mm, mm, mm. Even checking for this, yes, shit. Okay, whatever I have, I need to find. If it is bigger, 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 then keep taking it. Right, if it gets smaller, 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 then it's okay. But then if it gets bigger, then that smaller one, and then bigger one becomes J, or like the smaller one, smallest becomes I, then bigger, 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 the biggest, and then when I get a smaller one, that becomes K. So shit, it is doable in without this much. I don't need this. Repeat less. Go till 0. IJK. Forget about later and all that. I don't even need to know if it is sorted. I'm supposing that it is decreasing in the start. Decreasing equals 1. That it is decreasing, and I'll go on and see if it continues decreasing. If right, okay, and I would also like to have the last one. Last, right? And go from 1 into last. Now, if decreasing, if we are decreasing, then do this. If we are decreasing and and the current one is greater than the last one, and C greater than last. C is greater than last. Then first decreasing becomes equal to 0, and I becomes equal to The last one was I, and last index is equal to x. Means I am starting at x. Yes, last index is equal to L. Now, if not decreasing and C current one, and yes, fuck, after everything, L becomes equal to C, and C, the current one is smaller than the last one. Then J equals X and K equals X plus 1. It will not be equal, it will either be greater or smaller. Yep, makes sense. And after this, we are good to go. Right, and after this, I can do D equals 1, like D, which is like done. D equals 0, initially. Do one of this if not D. And even like this part. At the end, when would be the condition that I do not have anything? When I do not have the answer. Let's initialize I equals J equals K equals -1. Now, if K is not equal -1, then we know we have the answer. Then we know. See out. Yes, new line. I space new line J space K new line. Else see out. No. Okay. Yes. No shit. And 1, 2, 3. This is 1, 2, 3. Fucking awesome. It is called A3indices.cpp. A3indices.cpp and submit. Let's see. Prime agent. What are you building? I'm not building anything. I'm just solving questions here. What is the problem statement? Bro, what are you building? I am not building anything. I'm just solving code forces questions. And it is accepted. 3 indices. And now I guess the last one for today. 0-1 game. No, not the last one. It has only been 1.5 hours. It is already 7 o'clock here. 0-1 game. Alice and Bob are playing a game. That is cool. Actually, they have a binary string S consisting of only characters 0 and 1. Alice and Bob make alternating move. Alice makes the first move, Bob makes the second move, Alice makes the third, and so on. During each move, current player must choose two adjacent characters of string S and delete them. Okay, for example, if this is the string, then the following moves are possible. S1 and S2. Delete S1 and S2, delete S2 and S3, delete, yeah, okay. Any two adjacent characters I can delete, okay. If a player cannot make any moves, they lose. Both players play optimally. You have to determine if answer. Wait, what the fuck? Makes sense. If I delete, let's say, right, the sequence of zeros. Fuck, it is hard. Okay. Because if I get zeros in the starting, then they would not mean anything. And if there are no adjacent things, niyat. For each test, print answer in single line. If Alice can win, print the in any register. Otherwise, print niyat in Russian. The, do, and niyat. Not a net, niyat. The, niyat. That is cool. Okay. The niyat. If Alice can win, Alice can just remove these two. Fuck, it is a string. Is it just the length? It is just the length. Shit. Oh, why is this question here? Shit. It's not. So, okay. Divided by 2. Alice Bob, Alice Bob, Alice Bob. If I have 0, Alice Bob. If the number is even, like here, here, they will have full chances. But if the number is odd, then they won't be able to make a chance. So yeah. So the last player won't be able to make a chance. It will be something like that. So yeah. It's got size divided by 2 and this thing, and but before this, take its remainder by 2 and see what it is. And take its remainder by 2. In first case, 1. Alice is winning. If remainder does exist, then the, otherwise near. Okay, and this thing. See the net. And it's called 0-1 game. B 0-1 game. That is crazy. Is there something that there might could be something that I'm missing? B 0-1 game. I think it should not be this simple. It should not be this simple. The niet. Mm-hmm. Mm-hmm. Yeah, it should not be this simple. Let's see. Peak watching was 12 persons, 12 human beings. That is cool. Now for the second token. Okay. Answer was the. I got Nith for all of these are specially designed to fuck me up. Okay. Why is the answer Niyat in the first case? That Alice cannot. Okay. Now I get it. Okay. Consecutive zeros and ones, not just any number. Consecutive zeros or consecutive ones. Okay. Makes sense. Only character. In one move, they can. Alice and Bob. During each move, the current player must choose two different adjacent characters. Different adjacent. Okay, even though it is bold, I didn't read it. Okay, two different. This. Yeah, yeah. Makes sense. Makes sense. Makes sense. Yep. Yep. If they play optimally. Mm, yeah. Removing or adding some element does changes the number. Okay, if there is one, and remove that. If there is zero, keep 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 removing till there are one. Uh, what would be the time? when I don't have anything remaining. No legal moves either. All of them are one thing. Or yeah, shit. Or the string is completely gone. Hmm. Makes sense. In this case, if I remove a play optimally, let's say I did remove this one, then I can remove this one, 1 0, and then I can remove this 1 0 pair. And initially I had 3 zeros and 4 1s. So yeah, for every zero I'm removing 1 1. Yes, it depends on that, the number of zeros and the number of ones I have, and that is the number that will be remaining at the end. Okay, so the number of moves that I can make would be the size minus n, and end 0 and 1, and initially they are equal to 0, this also equal 0, and for auto c n else do this. If c equals 0, then 0 plus plus, else 1 plus plus. Now the number of move, all I have to do here is minus absolute difference of z minus o. Let's see, the neat shit, absolute difference. Yes, that is good. That is good. That is good. That is cool. That will work. I think that should work. Cool. Zero watching and second test. I don't know. Mhm, mhm, mhm. Will it work on second test? I think it should work on the second test. And it does work on the second test and on all the subsequent tests. I think it should work on all the tests and it should be accepted. Cool. Multiply 2 and divide by 6. Let's see. Uh, you are given an integer n. In one move, you can either multiply n by 2 or divide n by 6 if it is divisible by 6 without remainder. Okay, without remainder. Your task is to find the minimum number of moves needed to obtain 1 from n and determine if it is impossible to do that. Okay, you have to answer t independent tests. 0. No, not possible. Minus 1. 1, 2, 2. For this, 2. No, no, no. Shit. Okay. How many twos there are depends on how many threes. Okay. It is only reducing when I have 3. This would be minus 1. Okay. 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 10 and 6 and cn and see how many twos do I have in this thing. 2 is equal to 0 and 2 is equal to 0 and 3 is equals also 0 and yep. while n remainder with 2, you, as I don't have a remainder with 2, either this or n remainder, no, while 2, no, if n, if not n remainder with 2, if I don't have a remainder with 2, then 2 is plus plus, and if not, and also like this thing, and also n divided by 2, n divided equals to 2, and not n remainder by 3, then 3 is plus plus, and n divided by equal to 3. And still I do not want to check both the cases, but both of them could be true. I don't want to do else if, yeah, that would increase the number of times I'm going through the loop. Shit. Okay, maybe keep this in another loop, else break. Right. Now while true min, yeah, this else break, right, and then we are cool. Now if it should be, if n not equal to 1, then if n equal to 1, then we know we have our answer. And if n is not equal to 1, and I have more number or equal number of 3's, and 3 is either greater than or equal to 2 or 2's, that would be the only case when I do not have an answer. Otherwise I do have an answer. Minus line, new line. And what is the answer? I need to increase the number of 2's to make it equal to 6. So and answer equals 3's minus 2's plus, yeah, and this thing, yeah, out 3's minus 2's plus plus 3's. Yes, plus 3. Shit, that is cool. I can just do it. Shit, 2 into 3's minus 2's. Shit, yes. If they are equal, then also we are equal. Yes. Okay, b multiply by 2. Multiply by 2 and divide by 3. Yeah, multiply by 2, divide by 6. Cool, let's go. Of course, it is bullet case. Yep, bulletproof, won't fail, right? Yep, it should not fail. What's time? 45. It is taking time though. It is because of that. Is there a way to find out the number of, to find out this, yeah, to prime factorize a number? I think looping is the only way. Even if there is a built-in function, there might be a mathematical thing. Divide the number by for 12. Yeah, it is accepted, of course. But okay, it was 12. I got 3. Yeah, nah, that is not what I want. Yep, cool, all done. It's just these three. Detective editing, this and this. Okay. I have a few questions for ChatGPT. Let's see. If I have a number n in C++, how do I prime factor that number? Yes, to prime factor a number, start with the smallest prime number, to repeatedly divide n by the current f divisible, move to the next prime. Okay, yeah, shit, that is just it. Loop. Yeah, it is just looping. Let's see what are other people's solution for these things. Odd divisor. Yeah, starting from odd divisor. That is the one we did started with today. Odd divisor. I have a number. Yes, and an odd divisor greater than one. Okay, yes, n has an odd divisor greater than one. Yeah, just keep dividing it by two and see if it is. Yeah, what have other people done? A odd divisor A. Then A has any odd divisor. It has to be odd prime divisor. To understand this fact, we consider what happens when we multiply even and odd numbers. There is only one even prime, 2. So if a number has then it must be a power of 2. Yes, to check this, we can divide n by 2 as long as, okay, if at the end we get 1, then bonus, you can also use the following condition to check. Wait, this is what I have done, but there is also this condition. N minus 1. Shit, yes, if we are talking about binary things, then that one becomes equal to 0, and I can take XOR. Shit, if the number is equal to, you can how to take XOR in C++. I think with this thing, with bitwise XOR, yeah, with this thing. It is called odd divisor. Shit. Odd divisor, yes. Odd divisor in C, while if there is a remainder, then wait, what? While there is, yes, it has an odd divisor. Or instead of all this, I can do if n, this tilde, with n minus 1. Then this is beautiful. See out? No. Else? See out? Yes. It outputted no for all the cases. If it is 1, shit, okay, equals 1, and like this, this. Okay, if it is exactly equal to 1. If it was 1, but if it was 2, if it was 3, shit, shit. Yes, if it is 3, then we are messed up. Shit, yes. Then what I can do is if I subtract 1, mhm, it is only 1 in that case. Uh, XOR, if they are different, if they are different, exactly equal to 1, in that case. No, I don't. Shit. No, no, no. Yeah, it is horrible. I press that, then everything subtracting 1, everything becomes equal to 1, 1, 1, 1, 1, 1. And if I take, is there any bitwise manipulation? Shit, what was the thing in the tutorial? 1 followed by a bunch of zeros. If I subtract 1, then I should get 1, a string of 1s, and that is what I get, a string of 1s. How do I see if it is a string of 1s? How do I see if it is a string of 1s? Be before taking a XOR. Yes, fuck, it will be equal to 0. If this thing not equals 0. If if yeah, shit, if not this, okay. It is outputting yes in every case due to some reason, and never no. 1 0 0. Okay, and subtract 1, I get 1 1. So 1 0 0 XOR with 1. XOR is not the operation I'm looking for then. Nope, XOR is not the one I'm looking for. If they are different, then output 0, but if they are same, then output 1. And if they are 0 0 0, 1 1 should be. If, what is, what would that be? If they are different, not XOR, shit, XOR, uh, not XOR in C++. Bitwise operation in C++. XNOR. XNOR is, if they are same, then output 1. Yeah, XNOR. How do you get XNOR? So is this? Take the opposite of XNOR. 0 0, subtract 1 to get 1 1, take XOR, I should get 1 1 1, I should know 1 1 1s. It is outputting yes in every case. Why? It is never equal to 0. For 2, it should have been equal to 0. Say n is equal to 2 and 2 is 1 0 and 2 minus 1 is 1 and 1 is 0 1. So 1 0 XOR 0 1 is 1 1, that is 3, and not of 3 is 0. So, no. No? Is this the thing? Yeah, 0 1 1 0. It's the thing. 0 sheet. Is it because n is this? Wow. N is or n minus 1. I don't think there is any logical error in this thing. 1 followed by a bunch of zeros. Subtract 1 from that I would get a continuous string of ones, and take the XOR of the original with this one, I will get a string of ones, and take the NOT of that, I would get 0 0. That is what I'm checking for. And then no, I am doing code forces questions. This right here, CP31, that is a list of code forces questions that I'm going to do. I'm doing, yeah, that is it. And I guess I can end the stream now, or maybe first I have to solve this thing. Ask ChatGPT, because I don't think there is any problem in this case. In this, uh, this is wait, fuck you. I'm not going to ask ChatGPT. Tmux detach, and hello.cpp, paste this. Right, no, don't paste this. Include this iOS stream, and then main, and now paste it. Okay, std cn, and then cd cd. Right. Yep, this is what I would like to output also. Copy. Client plus hello.cpp. Out. Not slash out. And my number of choices is 4. -8. Fuck. Why? My bad. My bad. My mistake. Tmux attach TCP. My mistake. It is my mistake. Unsigned integer. Unsigned integer. That didn't work. unsigned integer. It is like always going to be positive. Yeah, and yes, shit, yeah, 1 0 would only result in 0. A bunch of zeros, then 1, and then a bunch of zeros. This hard. 0 0 0. Oh, that is cool. That is also adjustable. Now it is outputting no in every case because it is outputting less than 0 in every case. Fuck me. What was this thing in the tutorial? Mm. Hi, factual owl prime Eric. Shit. Why are you doing that? Are you any specific reason? What is your goal? Why didn't you use namespace? Answer all my comments. Why are you doing that? CP35 thing. Any specific reason behind that? Yes, I want to get better at competitive programming. And yeah, that would be done by practicing and reading theory. I have places to read theory from, and I have to do theory. I will be reading off stream, and I'm practicing here on a stream to get better at competitive programming. And it also helps me get better at logical thinking, which is very essential in programming in general. Let's go there. Editorial. He's taking and of these things, not XOR. What would and do if it is 2, 1, 0? Shit, shit, yes, that makes fucking sense. And, and, uh, this thing equals 0. Bruh, wrong answer for that last one. It became too large. A odd divisor. Right. Choose file. A odd divisor. A odd divisor. Answer all my comments. That is a crazy thing to say. Why would I answer all your comments? That is like you are ordering me. Okay. And that will be the end of today's stream. Uh, yep. That will be the end of today's stream. And yeah, goodbye. I will stream tomorrow now with CP and my other stream about building my own blog site.